This is a video for the review worksheet sections 5 through 8 of chapter 1, the biggie quiz. And so our first question is to find I to the 84, and I believe 84 is a multiple of 4. So remember, what you try to do is you try to find the closest multiple of 4, because we know that I to the 4th is 1, because it's I squared times I squared, and that's -1 times -1, so that's 1. And so that's why we try to find the closest multiple of 4, and then whatever's left over, we figure out. 5 plus 3i quantity squared means 5 plus 3i times the quantity 5 plus 3i. You cannot distribute that squared over a sum. Okay, so we multiply this out, we get 25, then that's going to be plus 15i, plus 15i would be plus 30i, and then plus 9i squared. And 9i squared is -9, and 25 plus -9 is 16. So our answer here is 16 plus 30i. And remember that it has to be in that order. If you write 30i plus 16, it's technically going to be incorrect. So 54, here's the way I like to do these problems. 54 is -54, the square root of -54. I take out the I first. And then 54 is 2 times 27. So it is 2 times 3 times 3 times 3, because 27 is 3 times 3 times 3. And then 24, -24, again, we take the I out, okay? And 24 is 3 times 8. And 8 is 2 times 2 times 2. So 3 times 2 times 2 times 2. And now I'm going to combine those. So the I times I is I squared. And then I have a 2 here and a 2 here. So 1 comes out, 1 disappears. I have a 3 here and a 3 here. So 1 comes out, the other one disappears. I have another 3 here and another 3 here. So 1 comes out and 1 disappears. And then I have another 2. So another 2 comes out and another 2 disappears. And so what we just found out is that what I had in there, if I'd have multiplied those together, I would have gotten a perfect square. I also would have gotten a much larger number that I would have had to do the prime factorization of. I prefer breaking them down and doing it this way. So then that looks like that's going to be -36. 6 times 6 is 36. I squared is -1, so -36. And then this next problem, we have 3 plus I, this is number 7. We have 3 plus I over 3 minus I. And you can't have I in the denominator of a fraction. And so the plan of attack is we multiply the top and bottom by the conjugate. And the conjugate of the denominator is 3 plus I, which makes it nice for the numerator. So that's going to be, when I multiply that out, it's going to be 9 plus 3i plus 3i would be 6i, and then plus I squared over 9, and it's going to be plus 3i minus 3i. Those are going to drop out, and I get minus I squared at the end there. Okay, so in the numerator, 9 plus -1 is 8 plus 6i, and 9 minus -1 is 10. And then if I can reduce everything by the same number, then I have to simplify that fraction, which I can. I divide everything by 2. I get 4 plus 3i all over 5. Nice answer. Number 8, we have x squared minus 4x equals 9. And of course, we'll write that as x squared minus 4x minus 9 equals 0. And that does not factor. So, what am I doing? What I was thinking is some of you still don't know the quadratic formula. And I don't want that to be a hindrance on the test. If you don't know the quadratic formula, then come back to my desk and ask, and I'll give it to you. I am not good at memorizing things. You know, I remember things because I've done these over and over and over and over again for 34 years. So even longer than that, if you count college and high school, or like 50 years. I don't want that to be a hindrance. If you don't know the quadratic formula, come and ask. But it is the opposite of b. So I'm going to put 4 plus or minus the square root of b squared. And I talked about this in class. That negative is getting squared with the b, with the number in front of x. So that's positive 16. And the quiz we took over this, I saw some negatives in there. And never. We don't say never very often in math, but that's one situation where I will. And then, why did I write plus? I got positive on the mind. I'm talking about 16 being positive. So minus 4 times a times c, which is negative 9. And I saw on that same quiz that I'm talking about, I saw a negative here and a negative here, and people still subtracted that. And no, you just see a negative here and a negative here, and that's going to turn that into an addition. So we get 4 plus or minus. This is going to be 16 plus 36. 16 plus 36 is 52. Turn the slide on if that would help. A little bit better maybe. Yeah. So 4 plus or minus the square root of 52 all over 2. And then 52 is 2 times 26, and that's 2 times 13. So that's going to simplify to 4 plus or minus 2 square root 13 all over 2. And then can I reduce everything by the same number except the radical, of course. I can't ever reduce that with a number on an outside that's not in a radical. So I'm going to get 2 plus or minus the square root of 13. And that's my answer. Okay. Number 9, we have 7x squared. Yeah, I'm going to move that 5x over all in one fell swoop. And then that's minus 2 equals 0. And I believe this factors. I believe, oops, you guys, sorry, factor puzzle. So 7x squared, negative 2, negative 5x. Obviously going to be 7x and x. I need the 1 here and the 2 here, so I get 7x and 2x, and I need the 7 negative, so that's negative. And so my answer is 7x plus 2 times the quantity x minus 1. And there's that zero product property all the way back from Algebra 1 that says if you have two things multiplied together to equal 0, then one of them is 0, or the other one is 0. And then we solve each one of these for x. I subtract 2, I divide by 7, I get negative 2 7s. I add 1 to both sides, so there's your two zeros, whatever you want to call it. Okay. And so then we have number 10, which is the square root of 3x plus 6 equals 2x plus 1. So it looks like I might have made this problem up, and so this might get ugly. But We're going to square both sides, which means over here I'm going to get 3x plus 6. And over here, I'm taking 2x plus 1 times 2x plus 1. Okay, so I'm going to get 4x squared, okay, plus 2x will be plus 4x plus 1. Since my x squared is positive and over here, I'm going to move everything over. So I'll have 0 equals 4x squared plus x minus 5. And gosh, that just might factor. Negative 5x, it's going to be 4x and x, and I need the 1 here and the 5 here, so 4x and 5x, and I need the 4 negative, right? So that gives me 0 equals 4x plus 5 and x minus 1. And this is going to give me x equals, subtract that, divide by that, so negative 5/4. And this gives me x equals 1. I'm going to check 1 first. So if I plug in 1, I get 3 plus 6 is 9. The square root of that is 3. And if I plug in 1 over here, I also get 3. So if there's going to be an extraneous root, I think we've talked about this, it's most likely, not always, most likely going to be the negative 1. And if I throw in negative 5/4 times 3 is negative 15 over 4 plus 6, which would be 24 over 4, which would be 9 over 4, which is 3 halves. So I would have 3 halves on the left. And then 2 times negative 5/4, which would be negative 5 halves, plus 1 is negative 3 halves on the right. And so that doesn't work. So that's my extraneous root, and my answer is 1. For 11, we have y equals 2x squared minus 4x plus 7. And we're supposed to do all the things, just all the things to this. We're going to find the vertex, we're going to find the domain and the range, the x-intercepts, the y-intercepts, the equation of the axis of symmetry, all the stuff, okay? I may not have all the room, enough room to do all the stuff, but I'm going to try. So first thing I like to do is go to the vertex, and I use the opposite of b over 2a because we are in standard form. So the opposite of b is going to be 4, and over 2a is going to be 4. So the x-coordinate of the vertex is 1. And then I like to plug that in right away. So that's going to be 2 times 1 squared, which is 2, minus 4 times 1 is 4, plus 7. So 2 minus 4 is negative 2, plus 7 is 5. And lo and behold, my vertex is 1, 5. Okay, which means my axis of symmetry, and the quiz that we just took today, because I'm doing this on Tuesday, the day we took that quiz, some of you just put the axis of symmetry as 1. Remember, it's the equation of a line, and it's the equation of a vertical line, so it is x equals 1. It will never be just the numeral, okay? Domain, all real numbers. Range, this parabola opens up, so the y's are going to be greater than or equal to 5. The y-intercept is going to be 0, 7. That's the beauty of being in standard form. The x-intercepts, I do not believe this factors. So I'm going to have to use a quadratic formula to find the x-intercepts. But I can graph 4, 5, 1, 2. I love showing off my counting skills. 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. Never understood that, like when they're going to do a dance routine and they start with 6, 7, 8. I don't, maybe somebody could explain that to me someday. So anyway, 1, 5 is here. And then 0, 7 is here. Using my axis of symmetry, I would have a point over here at 3, 7. Okay. Nope, I'm sorry. 2, 7. 2, 7 here. And I don't think I'm going to get 5 points plotted here. Because if I plug in 3, I'm going to get 18 minus 12 is 6. Plus 7 would be 13. And obviously I didn't go up to 13, so 3 points will have to do it. But I am glad, before I jumped into the quadratic formula, I am glad that I graphed it, because now that I see the graph, x-intercepts, the answer is none. There are none. It doesn't cross the x-axis. Now, if I asked you for the zeros instead, you would have to solve and say, you know, the zeros are whatever these imaginary conjugate roots are. Okay? All right. Number 12, last one. We have y equals x squared minus 2x minus 15. And so, again, we're in standard form. So we're going to use the opposite of b over 2a. So that's 1. Plug that in, I get 1 minus 2 minus 15. Oh, this is going to be ugly. That's negative 16. Thank goodness it opens up. The axis of, so the vertex is 1, negative 16. The axis of symmetry, remember, is the equation of the line, x equals 1, vertical line that goes through the vertex. The domain is going to be all real numbers. The range, as I said, it opens up. So my y's are greater than or equal to negative 16. And then my y-intercept is 0, negative 15. And my x-intercepts, I don't know. Let's graph it first. So I'm going to put my x-axis kind of way up here because I said so. No, because I need to go down to negative 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there's negative 5, negative 10, negative 15. My vertex is down here at negative 1, or 1, negative 16. And I have a y-intercept at 0, negative 15, which means I have another point over here at 2, negative 15. And I think I do have room to graph 2 more points. So I'm going to plug in 3. If I plug in 3, I get 9 minus 6. 9 minus 6 is 3. Minus 15 is negative 12. So 3 negative 12 would be right about there. Oh, that's way off. That's because my scales are not good. That means I should have another point over here at negative 1, 12. And wow, that's terrible. So there are x-intercepts. So now I set this thing equal to 0, and I see that it factors. Yay, factoring. Negative 15, negative 2x, so x and x, 5 and 3, 5x, 3x, and I need the 5 to be negative. So this factors to x minus 5 times the quantity x plus 3, 0. So x equals 5, x equals negative 3. Look at my graph, I almost hit the negative 3. 1, 2, 3. Oh, look, I hit the 5 exactly. You see that? Oh, you couldn't see that. There it is. I almost hit the negative 3, but I hit the 5 right on the nose. If you believe that. So my x-intercepts are 5, 0, and negative 3, 0. do not make this mistake of saying the x-intercepts are 5, negative 3, okay, like that, because that's an ordered pair. And obviously that's not what the x-intercepts are. Okay, that's an ordered pair, so no to that. If you don't want to write the ordered pairs 5, 0, negative, then you can just write 5, negative 3 separated by a comma, whatever. Okay, but not with parentheses. That's a big no-no. All right, that's it. That's all I have for tonight.